This next unit, we're going to be focusing on radical equations, and actually, radical equations are not too scary. We just have to be careful when we're thinking in the real world that we don't want to take the square root of a negative number. Okay, so we're going to have to restrict things to think of only taking the square root of 0 or more, so 0 and other positive numbers. Okay, so here's two examples for you. Example 1, we have a square root. Example 2, we have a cube root. Okay, so solving is a little bit different for each. So with the square root, we square both sides in order to cancel the radical. The cube root, we cube or take both sides to the third power in order to cancel out the radical. But in both, we still checked our answers to make sure that we did them correctly. Okay, now I also want you to notice that in both, we isolate the radical before we squared it or cubed it. Before we try to get rid of the radical, we isolate the radical, okay, using all the properties of solving that we know. It says, note, solving radical equations sometimes results in extraneous solutions. You must always check your answers by substituting them back into the original equation. Remember these steps, okay? Step 1, get the radical by itself. Well, in example 3, the radical is already by itself, so step 1 is done. Step 2, square or cube both sides. So I'm going to take this and I'm going to square both sides of the equation. The square root and the square cancel each other out, so I'm just left with what's underneath. 4 squared is 16. Please be careful because you cannot imagine how many people say 4 squared is 8. Okay, so just be careful. Now we're going to solve for x. We're going to get x by itself. So we'll add 3. We get x is equal to 19. But let's go back and check real quick just to make sure it works. So I'm going to take the original function and I'm going to substitute 19 for x. I'm going to put a question mark here because I'm checking to see, is that true? So is the square root of 16 equal to 4? Yes, we know that. We know that the square root of 16 is 4, so 4 is equal to 4. Okay? So let's go down and let's try another one. They're going to gradually get a little more complicated. So in example 4, to isolate the radical, we should subtract this 5 over. And that'll give us the square root of x plus 1 equals 11. Now that the radical is by itself, we can square both sides. And x plus 1 equals 121. We subtract the 1, and we're almost done. X is equal to 120. Okay, so go back and check that problem. So we have the square root of 120 plus 1 plus 5. We're checking to see, is that equal to 16? So the square root of 121 plus 5, is that equal to 16? And it is, because we have 11 plus 5, which gives us 16. Okay? Okay, let's look at example 5 real quick. In example 5, I can subtract the 1 first, because I want to isolate the radical. Now, we have a cube root, or a third root. So to get rid of this, we're going to take it to the third power. Now remember, when you have odd roots or odd powers, the sign's going to stay the same. With evens, they'll always end up being positive. But with odds, the sign will stay the same. So we have x minus 5 equals negative 8. We're going to add the 5 over, and we get x is equal to negative 3. Okay? Now we can check that one. So I can come over here. The cube root of negative 3 minus 5 plus 1, see if that's equal to negative 1. So the cube root of negative 8 plus 1. Okay? So we have negative 2 plus 1, and we know that that is, in fact, negative 1. So that one works as well. Okay? Now, I want to do another one with you, and then I'm going to give you a chance to work out a few of them, and then I want you to check your answers on those. So, number 6, we're going to isolate the radical. And in fact, the radical is this whole piece here. But the first step we need to do is subtract that 15. Now, the radical is still not by itself. But if I divide by 2, now it's by itself. Okay? So we can take both sides to the third power. So this one's a little more involved. And we're left with 3x minus 4 equals 27. Remember, to the third power means 3 times 3 times 3. So now we're just going to solve for x, old school. So you add the 4, and we get 31, and we divide by 3. Okay? Now, that's not pretty, so let's just leave it as 31 over 3. But when you substitute it back in, since you're multiplying x by 3, it's going to end up being pretty. Okay? Now, this is a long problem to check. So I'm going to just type it in my calculator, because I have a fancy calculator, and I'm going to see what happens. So let me show y'all how that works. Okay, so I'm going to type this in using parentheses. So I have 2 times. To bring up the cube root or any other root, we need to hit the math button. Option 4 is the cube root. So I have 3 times 31 over 3 minus 4. Okay, and I'm going to come outside. I'm going to close that radical. Plus 15, and we get 21. So we just checked. We got what was on the right side, so we're good to go. Okay? Now let's come back to the notes real quick. Why don't you guys try the next 3, and I'll come back and I'll show you the work for them so you can check them. Okay, check your answer for example 7 real quick. I checked it in my calculator, so make sure you do as well. Before you do number 8, you have a minus k over here, so change that to a minus x. Okay? I'm going to pause and work the next 2. Okay, now when we go to check example 9, let's see what happens here. So we've got the square root of 3 times negative 5 over 2 minus 2. We're going to see, is that equal to the square root of negative 5 over 2 minus 7. Okay? Now, here's the issue. When we go to figure this out, we're going to end up with imaginary solutions. Something that we can't quite find the square root of, because we're dealing with real numbers here. We want to know the real solutions to these equations. So on the right side, we have negative 5 over 2 minus 7. Just going to give you about negative 9.5. We like fractions, so negative 19 over 2. On the left side, we're also going to have a negative value. Now, even though they're the same, we don't want imaginary solutions. So we're not going to include this solution, and we're going to say no solution. Okay? All right, turn the page. Let's check these out. Okay, now 10 looks a little bit different because we have 10x minus 2 to the 1/3 minus 8 equals negative 4. Okay, so I'm going to start by trying to isolate that parentheses, because remember, the 1/3 power is the same as the cube root of 10x minus 2. So I have 10x minus 2 to the 1/3 equals 4. So instead of writing it in the cube root, I could just put a bracket around it and raise that whole thing to the 3rd power. Because when you multiply, or when you raise an exponent to a power, you're multiplying. Those exponents end up canceling. They just become 1. So we get 10x minus 2 equals 64. 10x equals 66. Okay, and x equals 66 over 10, which is 33 over 5. Okay, so we could go back and check that. So go back and check that in your calculator for me and make sure it works. And then I want you guys to work through the remaining problems on this page and then check your answers and work on the practice sheet for me. Okay? Actually, I'm back because number 11 looks a little different. Okay? So number 11, we can't really isolate the radical on the right side, so it's okay, leave that 3 there. But when we square both sides, we get 7x plus 2. On the right side, we get 3 squared, which is 9, times 3x minus 2. Okay? So let's check this out. I need to distribute that 9 on the right side. So we have 27x minus 18. Now I'm getting ready to solve, so I can subtract the 7x over, I can add the 18 over, and we end up with x equals 1. Okay? Plug that in, and it works. So always make sure that you check your answers. Okay? Now, I want you to be careful on number 14. So I'm going to show you a trick here. When you put this in parentheses to square it, remember that x minus 6 squared is x minus 6 times x minus 6. And be sure to check your solutions on that one. Okay, so I'm going to finish these up and I'll show you what we get. All right, check your answers for these. Then I'm going to scroll down, so pause if you need to. Now, I didn't always show my work for checking. I did on the first few, so check 13, 14, 15. So hit pause. And then 16, 17, 18. Okay? Make sure you have your homework complete when you come in tomorrow, and we'll address any issues.